They never let poor Rudolph go on any reindeer game. Then one soggy Christmas Eve, Santa came to say, Rudolph, with your nose so bright, won't you ride my sleigh tonight? Then how the reindeer love him. Dropped that ass on him, called him names. Ah, shit, brother. They never let poor Rudolph. Where the fuck are my. I can't. God, I'm trying to switch from using my damn favorites bar, and it's confusing the fuck out of me. Because you would think it'd be just so weird. I just want to get used to not having it, but man, it's. Ooh. You know what? I can just search. This is why I did this. I remember now. This is why I added the history tab so I wouldn't have to fuck around with that. Uh, there we go. Okay. I had a link that just took me here. Instead of just typing it, I just wanted to fucking find it, and then I got pissed off. Now it's all blown up. Why is it all big? All right. Yeah. Okay. Here we go. Here. So I'm gonna do this and learn NeoVim at the same time. It's actually really nice. I saw LazyVim, and it's exactly what I wanted because I wanted to use Helix, but Helix fucking the docs suck, bro. Like you know what? I'm in no rush. You're on my time here, whoever you are. So look, you come here, you hear good things. I had already been using it, but very minimally. But I wanted to lean into it. I'm like, okay, instead of just using it as a text editor for like config files, which is what I was basically what I was using it for. So look, I mean, it's nice. Like or let me bump into my Linux box here, so it's a reasonable file system. Okay, so well, first I found this thing. It's called Walk, but this is just an alias thing. Okay, but like this is what I wanted. I just wanted to be able to go like move through my fucking file system with some arrows, or you can use Vim keys too if you want. But it's super simple. That's all I want. It's all I fucking wanted, and I finally found it. And it's really cool because you can like backspace will go up a level. Enter goes will drill down, and but the cool thing is if you hit slash, then you can search desktop. Yeah, see, and then I can just pop in, and then when you can you can press spacebar and it'll give you a preview. A preview. Okay, it's not working right now, but well, I wonder why it ain't working. It should work. Oh, it might be blank. Actually, yeah, that might be an empty file. We'll find out. Okay, so like I know there's code, and I don't like routinely keep just empty shit. Yeah, it was a blank file. So yeah, so you can have the now I get a preview off to the right hand side. So even like this directory, it will show me the directories inside it. Isn't that sick? That's super sick. And you can just get rid of it. And so if I drill down and say, okay, there's my TS file. Okay, cool. But what if I want to edit it? Well, I just hit enter and then it opens it in my whatever you have defined as your default editor, which is Helix. So now you're in Helix, which is fine. Helix is cool, but well, let me show you why I liked it. Okay, so wait, hold on. Now I forgot how to. Okay, yeah. So you just hit spacebar, right? And you get this sick ass little menu here. This is great. This is what I wanted because I like the speed of it. I don't have time to put up a little cheat sheet. That's how I normally do is just make like a literal physical cheat sheet. But I was trying to find a way around that because that's also like it's hard for me to justify doing that and learning a new editor ahead of learning a new language and framework. So you know what I mean? Like, so I was trying to find something that could just tell you if you forget what these are, and that's exactly what this does. I was like, ooh, that is perfect. I want that. Like, even without me trying to explain this to you through my cracker in my mouth, you can see obviously what's going on. If I press capital D, I'll get the command next to capital D. If I press lowercase d, I'll get the command next to lowercase d. Awesome. No complaints about that. And it's really fast and has a really cool, look at the file picker. Look at how fucking fast this thing is, dude. This just it's searching my whole system. Well, everything in my home directory. It's so fucking fast. It just, like, look at that. So, I mean, for that purpose alone, it's incredible. And the fact that as I go down the list, right, on the right-hand side, just like the other program, this is not the same program, but they just both have this preview thing. But, I mean, Helix does it even better. And look, it's just very readable. It's like, it's super cool. I'm kind of like mad that I'm not using it now, honestly, now that I look at it. But the problem isn't having really anything to do with like being up in here unto itself. When you want to expand on it, and then I go to the docs, I'm like, all right, well, let me go learn more about how I can get syntax highlighting and like get the LSP set up for other languages, right? That kind of thing. I come here, you go to the docs as one does, and then you just start trying migrating. Like, here's my thing about it is like, what? Migrating from Vim, and this is the page I get, brother. I understand, like, yeah, there's links. I'm just saying, this, generally speaking, this is about the quality to expect. Yeah, you can follow the links, but it should be here. That's the whole point of your docs. And look, I mean, I'm not going to completely shit on it, but there's just a lot, you know, you can tell these guys are they're brilliant to the point where they've long since forgotten what it's like to be a beginner. And so there's so much assumption that gets baked in, and you'll figure that out. And that's par for the course, honestly. More often than not, you do get, it's not quite this bad, but most documentation does make a lot of assumption, and that's not necessarily incorrect. I think for an editor, I think it's incorrect for sure, especially if you're going to have the nerve to call it migrating from Vim as like a main header as a title. Okay, so that's what I'm saying. If it's going to be here presented in this way, it should be complete, not like a collection, a handful of bookmarks. Go here, motherfucker, figure it out. That's basically what they're saying to people. And so, you know, I have found that the documentation to be about that level across the board. That was just one example. Ergo, very time consuming. Not that it's not going to be awesome. It already has like 30-something thousand stars on it. So it's like, it's doing really well. Clearly people like it. I like it. You just saw it perform. I mean, it looks badass for one, and it's functionally awesome already, just as I mean, it is a text editor, but like, I mean, literally using it, I am just still using it and will continue to use it as a text editor, like text files that aren't source code. The stuff that I don't care, like, you know, like my bash RC or Zish RC, or like YAML files, or, you know, maybe some simple HTML, but not like big files, because then I want the highlighting for that. But like for stuff like Astro and stuff, I'm still just using VS Code. So now I want to move to a terminal editor, but like I need the fucking settings to work. And I'm like, you know what? I'm going to try LazyVim. Because LazyVim, I guess for the longest time, I just came across Helix first. I saw this YouTube video about it. And so I thought, no, like I want to try that. You know, fuck Vim. I want to try that instead. This is like the new Vim anyway, right? So I wanted to be on the hot shit. And it's good. I'm sure it's good. I'm just saying I'm a noob, so like I missed the wave. I'm not doing it right. So I need something easier. So I had to come to grips with that. You know what I mean? I'm glad I found this LK thing though, so now I can just back out. Blah, blah, blah. But anyway, so yeah, like this is the website that I'm working on. And so like if I open this in NVim now, after I installed the lazy Vim, so now I just open Vim, and then I get a very similar experience like to what Helix had. Now this is a framework, right? Like there's like I activated I don't know how to get there, but at least you get this menu. So like the crux of it was I wanted this kind of menu. So I'm like, okay, this is nice too. This is nothing to sneeze at, and it's I like it because it does a better job with the real estate. Like Helix kind of seems like it's in a contained window inside your window already for some reason. So I do like that better. And even though, how do I get there? I guess you? No. Go back. It was, where's the config? I literally just installed this earlier, so like it's a little, but isn't it pretty? I mean, it's just really good looking for one. So I'm already just happy to I'm just happy to be here, brother. But okay, no, seriously though, it was I could have sworn there was. Oh, how do I go back to? Yeah, what is this? It's like a config option. What? Oh, it does it too over here. Wait, is it doing that? It did. It like literally drilled down all the way up to what the hell? Oh, sick. Whoa, that is what it's doing. That SVG, where am I? Oh, I'm up in the website's favicons. Can I use my mouse on? You can't. This is incredible. How did I? Okay, hold on. Wait a minute. What's happening? Whatever. Okay, look. Let's just back up because clearly this is just as awesome. Um, this is so cool. Okay, I really did not know that it gave you this level of how do I don't know how to collapse things though. Fuck. Ooh, yes. Okay, so this is like what Helix looks like all the time. Um, whatever, that doesn't matter. The point is we're gonna now do this with Rust. So that's the fucking point. Oh yeah, I got sidetracked. I wanted to bitch about that for a little bit. Okay, here we go. All right, now I'm gonna shut up. Y'all, everybody, shut up. Actually, where did we stop? Because I don't remember. That looks important. We'll just stop here or start here. Oh yeah, but the premise. So okay, the premise is. Let's go back to that section because I forgot. Like, what are we gonna learn with this path here? A genuine question. I don't remember. Where is that at? Okay, well we can see here. Yeah. Okay. Right. We're gonna build an API. Build an API, and I think it's gonna show us some front end stuff too. What do they tell you? Like, who should read this book or what this book is for? Inside. I think it's here. No. I know it's oh, that's a nice graph actually. Yeah, okay, we're gonna deploy an app. So we're gonna build the API, do the logging. Yeah, so I mean effectively, yeah, end to end. Yeah, there's auth. Okay, sick. Yeah. So this will be great. So we're gonna do the whole thing tonight. No, not tonight. But we're gonna get a chunk of it done. So now I will shut up and let this old geezer teach us some Rust.
Chapter 1. Why Rust? This chapter covers the tooling that comes bundled with a standard Rust installation, a first glimpse of the Rust compiler and what makes it so unique, what is needed to write web services in Rust, features that support the maintainability of Rust applications. Rust is a systems programming language. Unlike an interpreted language like JavaScript or Ruby, Rust has a compiler like Go, C, or Swift.
My bad. I just gotta reset it because I kept fucking with the Zoom. But all right, let's start it back here.
Rust is a systems programming language. Unlike an interpreted language like JavaScript or Ruby, Rust has a compiler like Go, C, or Swift. It combines running with no overhead, like active garbage collection in Go or a virtual machine like Java, but offers easy-to-read syntax from Python and Ruby. Rust therefore performs as languages like C. This is all possible because of the compiler that safeguards any type errors and makes sure to eliminate many classical runtime errors, such as use after free, before you run your application. Rust offers performance. It has no runtime nor garbage collection. Safety. The compiler makes sure everything is memory safe, even in asynchronous environments. And productivity. Its built-in tooling around testing, documentation, and the package manager makes it a breeze to build and maintain. You might have heard about Rust, but after trying to go through the tutorials, the language seemed too complex, and you gave up learning it. However, Rust comes up as the most loved programming language on the yearly Stack Overflow surveys, and has found a large following in corporations like Facebook, Google, Apple, and Microsoft. This book will unblock you and show you how to become comfortable with the basics of Rust and how to build and ship solid web services with it. Note: this book assumes you have written a few small Rust applications and are familiar with the general concepts of a web service. We will go through all the basic Rust language features and how to use them in this book, but more as a refresher than as a deep learning experience. If you have read through Chapter 6 of The Rust Programming Language by Steve Klabnik and Carol Nichols, see this link. For example, you are fine and won't face any trouble following along with the exercises presented in this book. The book covers Rust 2021 and is backward compatible with version 2018. For you as a developer, Rust provides a unique chance to broaden your horizons. You might be a front-end developer who wants to get into back-end development, or a Java developer who wants to learn a new language. Rust is so versatile that learning it can expand the kinds of systems on which you are able to work. You can use Rust wherever you can use C++ or C, but also in a situation where you would use Node.js, Java, or Ruby. It is even beginning to find a foothold in the machine learning ecosystem where Python has dominated for years. In addition, Rust is great for compiling to WebAssembly, webassembly.org, and many modern blockchain implementations, Cosmos, Polkadot, are written in Rust. The longer you spend writing code and the more programming languages you learn, the more you realize that the most important things are the concepts you learn and using the programming language best suited to the problem. This book, therefore, does not stop at just showing you which lines of Rust code enable you to make HTTP requests. It describes how web services work in general, as well as the underlying concepts behind asynchronous Rust, so that you can pick the transmission control protocol, TCP, abstraction that works best for you. Section 1.1, Battery.
Sorry, I was chewing on a cracker. Just to mention, all that shit that's flashing is just like the plugins in NeoVim are lazy loaded, which is kind of weird. But that's all that is. As far as, I mean, that's my understanding. I've been using VS Code, and that's like, I know it just downloads literally everything because the first time you run it, it's like pretty damn slow. You know, if you're doing a sync. or a new install or something like that. You got all these plugins like I do that you don't fucking need, but I mean they look cool, so like I grab them. But then you go to a new machine or you like remote in SSH, and then it sets up all that shit, so it takes a long time up front. That's not the case here. It's like lazy load, so you just loads it whenever it needs it. But yeah, that's what that was.
Section 1.1, Batteries Included, Rust's Tooling. Rust comes with the right amount of tooling to make starting, maintaining, and building applications straightforward. Figure 1.1 gives you an overview of the most important tools you need to get started writing Rust applications.
Figure 1.1. All the tools you need to write and deliver Rust applications with.
You can download RustUp and install Rust by executing the command on the terminal shown in Listing 1.1. This works on Mac OS via brew install rustup-init and Linux. For an up-to-date way to install Rust on Windows, follow the instructions on the Rust website at this link.
Listing 1.1. Installing Rust.
The command line tool curl is built to transfer data with URLs. You can fetch remote files and download them onto your computer. The option --proto enables the use of protocols like Hypertext Transfer Protocol Secure, HTTPS, which we use. With the parameter --TLSV 1.2, we use Transport Layer Security, see this link, in version 1.2. Next comes the URL, which, if we open it via the browser, offers a shell script to download. This shell script is getting piped, via the vertical bar, to the sh command line tool, which executes it. This shell script will also install the tool RustUp, which lets you update Rust and install helper components. Updating Rust is as easy as running the command RustUp update.
See this code.
And if you want to install more components like the code formatter mentioned in Figure 1.1, you use RustUp as well.
Listing 1.2. Installing Rust FMT.
Running this tool via Cargo FMT will check your code against a style guide and formats the code accordingly for you. You have to specify the folder or file you want to run it for. You can, for example, navigate to the root folder of your project and run cargo fmt dot with a dot to run it for all directories.
Hold on, what's going on? I thought I was already set up here, so I was kind of fucking around. I guess I really should be doing this. You can download RustUp and install Rust. I thought I did. Oh, I did it through ASDF though. I guess it's not all that after all. Oops. Because it's not behaving the same way. I'm not trying to. What's the problem? What'd I do? What? URL rejected. No host part. Oh. I see. You can download the work on back for an up-to-date way. Gotcha. That might help. Payal, baby. If I put an actual URL on there. Okay. Not enforcing cipher, not enforcing. It looks like you have an existing. He's recommended that RustUp be the primary Rust install. Yes. Otherwise. Or set up to yes. Or pass Y. Oh, I see. Okay, okay. So ASDF uninstall Rust. Where Rust? Actually, yeah. I think that's what it is. So this should work now. Just kidding. ASDF. Wait. It didn't throw an error. How do I... Oh, remove. No, uninstall. It is uninstall. Okay, ASDF. Uninstall. Rust latest. Fucking all of them. Or not Rust. Oh, actually, I know what I can do. I'm being a goob. Alright. Just fucking get rid of you. Get out of my path. Oh, God. There you are. You. SSH there. My brew. Dino. Dana. Oh, more of them. Golly, how many are there? Oh, for cargo. And how do I do a whole line? I guess I can't. Because I don't know how. And there's Zish. Herd. Fucking PHP sucks dick, dude. All that Laravel shit. Whatever. Fuck off. Fucking sucks. I fucking drank the Kool-Aid on that. Got tricked. It's all a fucking cult, dude. Don't get tricked by Laravel. Oh, we got everything, brother. Yeah, it's still fucking PHP. It fucking sucks, dude. Don't do it. Don't waste your time. You will regret it, I would say. And I'm just not gonna remove that though, because I'm just not gonna do it. WQ. Which cargo? Has to still see it, man. Get the fuck out of here. Ah. You don't exist, brother. And then, okay, so now let me run. Fuck, where? No, I don't want it to be all fucked up. Which ASDF plugin remove Rust and cargo. No. Rust C should be on the other Rust cargo. Maybe I just need a new terminal. What? Oh, because I'm up in this directory. Ah, shit. God damn it. It's too late. I'm not tired yet, though. There we go. There we go. Okay. Will be installed. Okay, sure, brother. Can be modified. Zish M. Okay. Ash, Dash, and Pudksh. I never even heard of those, dude. Ash. Let me not fuck around with that. I don't know why I did that. Rust up. I don't think you just call. Yeah, okay, you don't do that. And then there's a Rust C. Yeah, okay. Okay. Got it. Good.
The command line tool curl is built to transfer data with URLs. You can fetch remote files and download them onto your computer. The option --proto enables the use of protocols like Hypertext Transfer Protocol Secure, HTTPS, which we use. With the parameter --TLSV 1.2, we use Transport Layer Security, see this link, in version 1.2. Next comes the URL, which, if we open it via the browser, offers a shell script to download. This shell script is getting piped, via the vertical bar, to the sh command line tool, which executes it. This shell script will also install the tool RustUp, which lets you update Rust and install helper components. Updating Rust is as easy as running the command RustUp update.
See this code.
And if you want to install more components, like the code formatter mentioned in Figure 1.1, you use RustUp as well.
Listing 1.2. Installing Rust FMT.
Running this tool via Cargo FMT will check your code against a style guide and formats the code accordingly for you. You have to specify the folder or file you want to run it for. You can, for example, navigate to the root folder of your project and run cargo fmt dot, with a dot, to run it for all directories and files. After executing the curl command in listing 1.1, we not only have the Rust library installed, but also the package manager Cargo. This will let us create and run Rust projects. With this in mind, let's create and execute our first Rust program. The following listing shows how to run a Rust application. The command cargo run will execute Rust C, compile the code, and run the produced binary.
Listing 1.3. Running our first Rust program.
Our new program prints Hello World to the console, and we see shortly why. Looking inside our project folder, Hello, we see the files and folders listed in listing 1.4. The command cargo new creates a new folder with the name we specify, and also initializes a new Git structure for it.
Listing 1.4. Folder contents of a new Rust project.
The command cargo run will build the application and execute the binary, which lives inside the ./target/debug folder. Our source code lives in the src folder. Depending on the type of application we are building, this folder has either a main.rs or lib.rs file in it with the following content.
Listing 1.5. The auto-generated main.rs file.
In Chapter 5, you will see the difference between the lib.rs and main.rs files, and when Cargo creates which one. The folder target contains another folder called debug, which contains our compiled code, generated by the cargo run command. A simple cargo build would have had the same effect, but would just build and not execute our program. When building a Rust program, the Rust compiler, Rust-C, is creating Rust bytecode and passes it on to another compiler called LLVM, llvm.org, to create machine code. LLVM is also used by languages like Swift and Scala and turns bytecode produced by the language compiler into machine code for the operating system to run. This means Rust can be compiled on whatever operating system LLVM supports. The whole stack is shown in Figure 1.2.
Figure 1.2. After installing RustUp, you have the Rust standard library on your machine, which includes...
Hold on, how do you just fucking run a shell command from here? Because you're like already in the terminal, but you're also in your editor. It's really weird thing to get used to. AI. How about a fucking letter for the terminal? How do I get to the fucking W? W. NeoTree file system. I just wanna. Is it you? No. Maybe you're just supposed to. Yeah. Okay. Maybe that's. Yeah. Okay. I didn't think about that. I could just do the old splitty thingy. I wish I could make it a little square. Oh well. It'll just be skinny. And then... Oh, I thought it would take me there. I did. Rusty web flap. Here. Yeah, baby. Fucking bitch. All right.
Figure 1.2. After installing RustUp, you have the Rust standard library on your machine, which includes the Rust compiler.
Another important file is cargo.toml. As we see in Listing 1.6, it contains the overall information about our project and specifies the third-party dependencies if necessary. Note: when developing libraries, the cargo.lock file should not get checked into your version control system, like Git. But when creating an application, binary, you should add the file to your version control system. Applications, binaries, are often dependent on specific versions of an external library, and therefore other developers you are working with need to know which versions are safe to install or have to be updated to. Libraries, on the other hand, should function on the latest version of used libraries.
Listing 1.6. Contents of a cargo.toml file.
Installing third-party libraries happens by adding the names of the dependencies under the Dependencies section and running cargo run or cargo build. This will fetch the libraries, called crates in the Rust community, from crates.io, the Rust package registry. The actual fetched version of the installed packages appears in a new file called cargo.lock. If the file is in the root folder of your project, Cargo will fetch exactly the version of the packages specified in the cargo.lock file. This will help developers working on the same codebase to replicate the exact same state across different machines. TOML file. The TOML file format is like JavaScript Object Notation, JSON, or YAML ain't markup language, YAML, a configuration file format. It means Tom's obvious minimal language, and as the name suggests, should make configuration.
I didn't know that's what that stood for. YAML ain't markup language. That's funny. Okay, I missed this part. What are you talking about? I just want to hear this part again. Page.
Figure 1.2. After installing RustUp, you have the Rust standard library on your machine, which includes the Rust compiler.
Another important file is cargo.toml. As we see in listing 1.6, it contains the overall information about our project and specifies the third-party dependencies if necessary. Note: when developing libraries, the cargo.lock file should not get checked into your version control system, like Git. But when creating an application, binary, you should add the file to your version control system. Applications, binaries, are often dependent on specific versions of an external library, and therefore other developers you are working with need to know which versions are safe to install or have to be updated to. Libraries, on the other hand, should function on the latest version of used libraries.
Listing 1.6. Contents of a cargo.toml file.
Installing third-party libraries happens by adding the names of the dependencies under the Dependencies section and running cargo run or cargo build. This will fetch the libraries, called crates in the Rust community, from crates.io, the Rust package registry. The actual fetched version of the installed packages appears in a new file called cargo.lock. If the file is in the root folder of your project, Cargo will fetch exactly the version of the packages specified in the cargo.lock file. This will help developers working on the same codebase to replicate the exact same state across different machines. TOML file. The TOML file format is like JavaScript Object Notation, JSON, or YAML ain't markup language, YAML, a configuration file format. It means Tom's obvious minimal language, and as the name suggests, should make configurations easy to read and parse. The package manager Cargo uses this file to install dependencies and populate information about the project. To quote one of the Rust core members, "It is the least terrible option. See this link." This doesn't mean that TOML is bad, but just that there are always trade-offs when handling configuration files. The last tool in our belt is the official code linter Clippy. This tool is included now by default when installing Rust. It can also be installed manually if you operate on older Rust versions.
Listing 1.7. Installing Clippy.
Chapter 5 introduces the use of Clippy and details how to configure it. Section 1.2, the Rust compiler. The advantages of using Rust versus other languages is its compiler. Rust compiles down to binary code with no garbage collection invoked at runtime. This gives you C-like speed. In contrast to C, however, the Rust compiler enforces memory safety at compile time. Figure 1.3 shows the differences between popular programming languages used for server-side programming and C.
Figure 1.3. Comparing Rust and other languages in compiling machine code from source code.
Each language has trade-offs. Go is the newest of the demonstrated languages and comes closest to the speed of C. It uses a runtime for garbage collection and therefore operates with a bit more overhead than Rust does. Go's compiler is faster than Rust's. Go aims for simplicity and takes a small runtime performance hit to do so. You see that Rust offers no runtime overhead, and because of the compiler, offers more comfort and safety while writing code than Go or JavaScript, for example. Java and JavaScript require a, sort of, virtual machine for running the code. This results in a heavy performance penalty. One of the adjustments you will have to make when writing programs in Rust is to work with the Rust compiler to build applications. When you come from a scripting language, this is a huge shift in mindset. Instead of starting an application in a few seconds and debugging it until it fails, the Rust compiler will make sure everything works fine before it starts. For example, consider this code snippet from later in the book, just printed here for demo purposes.
Listing 1.8. Checking for an empty ID.
If you cannot read this code snippet yet, don't worry. You will soon. That's a match block, and the compiler makes sure we cover every use case, whether ID is empty or not. If we delete the line with true goes to and try to compile our code, we will get an error.
Listing 1.9. Compiler error for a missing pattern matching.
The compiler highlights the line and the exact position in our statement, and in addition gives a suggestion for solving the issue at hand. It is designed to produce error messages that are understandable and readable by humans, rather than just exposing the internal parser error. First, making sure the program operates correctly in all use cases might seem tedious in small applications, but once you have to maintain larger systems and add or remove features, you will quickly see how writing Rust can sometimes feel like you are cheating, since so many issues you had to think about in the past will now be covered by the compiler. It is therefore seldom that you will be able to run newly written Rust code right away.
Yeah, so one of the things, I mean, I hate to say this because it's obviously not true, but I think semi-useful in the sense that since we've already covered Swift on this stream, if you happen to be around for that, then you already kind of know Rust, which was a nice surprise for me. So Swift protocols are Rust traits. Like they do the exact same thing in terms of like, they're like reverse inheritance, more like guardrails for, it's a type. It's a type. It's a way to group a certain shape of a struct or an object, or require that it has certain methods. It's like literally Swift protocols. So everything is top down from that perspective. It's like everything they're talking about in terms of like the compiler is enforcing it for you. If you're around for Swift, it's doing what protocols were doing. So that's like a direct parallel. Something I learned so far, which is really cool. So we're ahead of the game.
It is therefore seldom that you will be able to run newly written Rust code right away. The compiler will be part of your daily routine and help you understand where to improve your code and what you might have forgotten to cover. You can't jump quickly into Rust as you can, for example, into JavaScript or even Go. You need to become familiar with a set of basic concepts first. In addition, you must learn many aspects of Rust to become a proficient Rust developer. That said, you do not need to know everything to get started. You can learn as you go with the help of the compiler. You see, the Rust compiler is one of the strongest arguments for using Rust. Once you've become proficient, you can use Rust in multiple areas: game development, back-end servers, machine learning, and maybe soon Linux kernel development. This is currently an ongoing discussion and trial phase. See this link. If you develop applications in a larger team, it helps to know that newly trained Rust programmers must pass through the compiler first before they can contribute to the codebase. This will already cover a huge amount of code review and guarantees a baseline of code quality. Section 1.3, Rust for Web Services. We covered the main reasons we might choose Rust over other programming languages. Let's look at how we can start writing web services with it. Surprisingly, Rust doesn't cover as much ground when it comes to HTTP as, for example, Go or Node.js. Since Rust is a systems programming language, the Rust community decided to leave efforts around implementing HTTP and other features to the community. Figure 1.4 shows a typical tech stack of a web service, and to which degree Rust offers.
And suddenly I'm sleepy, so we will pick this up tomorrow. Oh man. All that yapping, no coding, but hey, you know what?